Good evening. Uh, this is our Beginners Academy Zoom meeting. We have an audience tonight, and we're doing a presentation on NVIS and Whisper. It is NVIS experiment technique using Whisper. And hams are in their ham journey, they come across these things. I think some of these things were on the test. But anyway, we hope it kind of fills out some knowledge about NVIS and Whisper, and I'm still learning about it. And we have a diagram there. It involves HF signals and the ionosphere, and it's a way to cover shorter distances than most the higher bands cover, and we'll get into those details. I'm including some material I borrowed from Elizabeth Klein, KE8FMJ. She had done a talk or a little article for On All Bands. That's sponsored by DX Engineering. All right, well, the four letters NVIS and ham radio means near vertical incident skywave. And it's used for local to medium distances on HF. The radio waves for NVIS travel nearly vertical upwards into the ionosphere where they're refracted back down. And it fills the gap between line of sight and the longer skip type communications that are normally used on HF. And the most reliable frequencies for NVIS communications are between 1.8 and 8 megahertz. All right, well, HF communications for distance depends on the layers of the ionosphere, and for distant communications, primarily the F2 layer. And you see a long arc there of a signal starting on the left and refracting off the F2 layer of the ionosphere. And if you're on 20 meters, like sideband, you may notice that you only hear one side of the conversation. And that could be because the other station in the conversation is in the skip zone. So basically your transmitted signal and your received signal is skipping over a good part of the country. And that is called the skip zone. Well, NVIS communications can somewhat fill in the zone, and it's usually on what I'll call the lower bands, 80 and 40 and so forth, meter bands. And so sometimes people doing awards, they have the hardest time talking to people near them. And for myself, I operate portable, but I like to talk to my friends that are within 100 miles or so in Dothan and Panama City. And I can do that most effectively when the conditions are good for NVIS and I have the right antenna for NVIS. So for this to work, your signal must take off at a high angle, about 60 to 90 degrees from the antenna. And the signal gets returned at a similar angle. So that's the way to fill in the skip or dead zone. And it turns out that if your frequency is too high, your signal at high angles will pass through the ionosphere and not return to Earth. So there's some body of knowledge that you'll need to effectively use NVIS. This diagram shows the D layer, the F1 layer, and the F2 layer. The D layer for these types of signals tends to absorb the wave, your electromagnetic wave, and that actually in the daytime, the D layer is the strongest. So on 40 and 80 meters is pretty much dead in the daytime, and that's because of the D layer. 40 meters is usable, but there's more absorption during the daytime from the D layer. And your NVIS signal and a skip signal both go through the D layer, but your low angle wave is going to go through more of the D layer. And anyway, it's a nuance, but I've heard that QRP works pretty well with NVIS because the time that the signal or wave spends in the D layer is kind of minimized. All right. For us that have been around for a long time and listen to AM radio, we're familiar with, in the daytime, you hear the strong AM stations, but it's completely different at night. You can pretty much hear almost all the stations because the D layer is reduced and there's less absorption. So, all right, well, what do we know about these layers? Well, the governments and scientific organizations have been studying this, and they have instruments that can characterize the layers pretty much in real time. And there are ionosomes or digisomes that are all over the world. Maybe there's 50 of them. I'm just guessing at that number. But anyway, they're like HF radar, and they focus their signal straight up, and they look for a reflected signal. And this diagram is an ionogram, and it's kind of a typical ionogram that shows the height of the E layer, the F1 layer, and the F2 layer. And most importantly, there's on the F2 layer, as you go to the right, there'll be the frequency where the reflections stop. And that's known as the FOF2. It's also known as a critical frequency. And that's very important for NVIS because if you're above the critical frequency, you're not going to get the high angle reflections or refractions off the F2 layer. So NVIS isn't going to work. And so you may have the equipment, you may have the antenna, but unless the ionosphere is cooperating, it won't work for you. And in particular, I like 40-meter NVIS because I generally don't get on 80 meters for portable operations. So I do have portable antennas for 40 meters. And for 40-meter NVIS, the FOF2 or critical frequency needs to be above 7 megahertz, the bottom of the band. And FOF2 is the frequency where signals going straight up are reflected instead of going into space. Now, I'll bring in the ionosone here because we were fortunate to have a ionosone at Eglin Air Force Base, which is in Northwest Florida. So we can get some information about the critical frequency from from the web, basically. And it's generated by the ionosone at Eglin. Of course, if you live in a different part of the world, there'll be a different ionosone near you. Okay, well, during the lower part of the solar cycle, when sunspots are fewer, FOF2 is almost always below 7 megahertz. So NVIS isn't going to work on 40 meters. And the solar cycles are pretty long, so there's been quite a bit of time that NVIS hasn't been good on 40 meters. But in solar cycle 25, the current cycle, the sunspots and so forth are on an uptick. And NVIS on 40 meters is now possible because of the better ionization of the F2 layer, which raises the critical frequency above 7 megahertz. All right, well, there's a lot of discussion about NVIS and the antennas, and sometimes they leave out this important part. Now, I found a page for the Eglin system that gives you a chart of the basically FOF2, and you can look at this at any time. And the blue trace, of course, this isn't in real time here, but the blue trace is the current day. The red trace is the previous day. And all the other little squigglies are from the last 5 days. So as you can see, well, this is in UTC. So a couple of hours after the UTC day begins, things are still good. That the critical frequency is around 7 or higher. But during the night, the band goes long, as they say, and it's not good for short communication. And then in the morning, it comes back up. Well, I'm going to talk about an experiment I did on Saturday, and it turned out that I did it. It just happened that the critical frequency was just above 7. So there wasn't much margin there. So I was in this little trough, which kind of happens, you know, in the day. But you can see by these squigglies, it can vary quite a bit from day to day. But there's a general pattern to this, and then there's variations. And this plot can look quite different at different times in the solar cycle. I have a link for this that I can send out. And since we talked about the solar cycle, this is the current cycle. And they're plotting some data here. The bell-shaped curve is the predicted solar cycle. But you can see they're plotting some data there as we progress into 2022, and it's really exceeded the predicted value. And it will be a different discussion, but there is one group that predicted that it would be greater than what the consensus prediction was. So,
hey, Greg.
Yes.
How do you figure they calculated these sunspot cycles back in the 1800s?
Well, it was by counting sunspots.
Oh, okay.
Sounds like a very dangerous activity, doesn't it?
Aim your telescope at the sun. That sounds pretty dangerous.
Well, they filter. Yeah,
I hope.
the fellow that's hitting the nail on the head is Scott McIntosh, and he's doing a Zoom presentation in about 2 weeks. If anyone's interested, fire me an email and I can send you a link to that.
Yeah.
But what he did was he said NOAA and these other people that are predicting the red line there are looking at the past cycle to predict the next cycle, and he found a more accurate way of thinking was to look at the period of the last cycle to predict the next cycle. And he back calculated back to the 1800s and found it was much, much more accurate. And this basically his prediction is following the purple line pretty well right on.
Yeah.
He's quite a character, Scott McIntosh. There's YouTubes and stuff on him too.
Yeah.
He's worth listening to. He gets technical pretty quickly, but he's still quite a presenter. So
Yeah, I'm glad you gave those details. That's really what I was referring to with that.
yeah, he's the renegade.
Yeah.
The renegade that got it right. Anyhow, carry on, Greg. Sorry to interrupt.
It's okay. Well, if they can't predict the solar cycle,
what can they predict?
I'm unsure about what else they can predict. So, all right. Well, this could be a subject of another discussion, but you hear these things, and frankly, it took me years and years to, even when I read about it, I didn't necessarily get it. So it just eventually starts sinking in. Of course, the fast learners already got it. All right. Well, what about antennas for NVIS? I'm not going to go in a lot of details, but chances are you have an NVIS antenna. If you have a horizontally polarized antenna, it's probably going to have a pattern somewhat like what's shown on the left. There's going to be a lot of radiation straight up, and that's because horizontal antennas that are not very high in terms of wavelength, the pattern, you get reflections off the ground and it radiates at high angles, and it's great for NVIS. So if you have a 40-meter antenna, chances are, not most of us don't have it very high, and so if we had the ultimate 40-meter antenna at maybe 130 feet or 66 feet, the pattern might have lower angles. But this can be very good for NVIS. You'll see antennas tuned for NVIS And I may do some experiments with that, but just just my gut feeling is that most of our antennas end up being NVIS. So you're lucky you've already got one. Of course, a vertical, however, does not have radiation at high angles. It tends to have them at low to medium angles. So it would be a very poor NVIS antenna. Well, I've given some background, but why did this come up? It's come up because I did a little impromptu experiment on Saturday, and I have attained some whisper beacons, and I wanted to try them out, and I'm interested in NVIS. And so I live in Dothan, Alabama, and about 40 miles away is the rocket launch site for the Southeast Alabama Rocketry Society. So since I was going, I took the beacons, and I happen to have two antennas. One is on the left. It's a link dipole. It's not very photogenic because you can almost not see it, but it's a dipole in a inverted V fashion. It only has one support in the middle. And on the right is the Alex loop mag loop. And it's not advertised as an NVIS antenna, but I've had very good NVIS contacts with it. And actually with loops, you can have a radiation and reception at the top of at high angles. It's one reason that a loop is not the ultimate directional antenna, because your directionality can kind of be poisoned by high angle signals. But I've done parts on the air with the loop, which is not very efficient at 40 meters, but nevertheless, I'm always excited about making contacts with it.
What is the expected antenna pattern of a mag loop?
Well, it is mildly directional, and the best reception is in the plane of the loop. Okay. Now, most people, or people might think, well, you want the loop facing the preferred direction, but it's in the plane of the loop.
Okay.
So there's really a null going through the loop, so to speak.
Gotcha. Thanks.
So it's not a highly directional, but I will turn the loop to kind of peak things up. It makes a little bit of difference, particularly on 20 meters and up. For 40 meters, if it's NVIS, it's not going to, and that's one thing I noticed. If I turn the loop, it didn't make any difference. And that's because the signal was coming in at a high angle, and the loop looks the same, no matter which way you turn it. So, yeah. So probably nobody runs out and to get a loop to do NVIS, but it does work for it. All right. So, we've covered one 4-letter acronym or whatever. The other one is WSPR, which is Weak Signal Propagation Reporter, which is really a tool that was designed to investigate propagation, and it was developed by Joe Taylor, who did FT8. And really, I think NVIS probably came before FT8. And it is not really a communication protocol, but there are beacons around the world, and there are receiving stations around the world. So you can get a picture of what the propagation is. And the WSPR protocol doesn't carry a lot of information, but it does carry the grid locator, the Maidenhead grid locator, like EM70 is down in Florida. Bay County is in EM70. And the transmitter power in dBm. Okay. It doesn't take very much power to do NVIS because the program can decode signals with a signal to noise ratio as low as -28 dB and a 2500 hertz bandwidth. And this information can be aggregated and made available on the web via a central database called WSPRnet, which includes a mapping facility. There's also other tools out there. So that brings us to Harry. Actually, there are a lot of different, it doesn't take a whole lot to create a beacon. And there's a lot of little modules available. But this one I recently, the specifications are on the next page. But anyway, I believe Harry is in Sweden and he's holding what he calls the desktop WSPR transmitter. But that's a little bit of a misnomer because it's an excellent field transmitter. And I have two of them now, so I took them to the field to do an NVIS experiment. Here's some details about the WSPR desktop transmitter. It has a program that you can use to configure it, but after you configure it, it doesn't require the computer anymore. So I configured the two beacons for 40 meters. And when I took them out to the field, I plugged them in, hooked them up, plugged them in, and they started working on 40 meters. No muss, no fuss. And it's kind of impressive that it's not a one band thing. And so there's a big frequency range, but there's different models within that frequency range. The one that I have is model 80 to 10, which covers 80 meters to 10 meters, or 3.5 megahertz to 28 megahertz. But if you were interested in extremely low frequencies, there's a model for you. And so there's 4 different models. I think it'd be cool to have one that covered 6 meters. So the output is 200 milliwatts. So it doesn't take a lot of power. I used a USB power pack to power both of them. One really cool feature is that it has GPS, includes a GPS antenna, and the timing is derived from GPS. So it knows when to start the beacon sequence, which is on every other even minutes. Okay. And it also figures out the grid square. So for me, if I wanted to, I could take these to out camping just for fun, and it would automatically know my grid square, and it would be essentially plug and play. Also, one more thing, you can configure it if your antenna will work on all the bands, you can configure it. You can select which bands you want it to operate on, and it will sequence through those bands. Then it will take a breather and sequence back through it. So anyway, a very cool device. So my impromptu, this is not the greatest NVIS experiment, but the impromptu experiment that I thought up on Friday to do on Saturday is to take these beacons to the rocket launch at Sampson, Alabama. Both were programmed for 40 meters. All I had to do was plug and play. I hooked one to my Soda Beams link dipole, which was set up for 40 meters. The other was hooked up to the Alex loop mag loop. And another part of this, I had never done it before, but I used the WSFT-X software as a whisper receiver. So if you've been playing with FT8, all you have to do is change your mode to whisper, and you can receive signals on your chosen band. You can also transmit. I haven't done that yet. So chances are you're already whisper capable. I did have a horizontal infed antenna here that I hooked it up to. So 40 miles from the launch site to Dothan, and that's pretty extreme NVIS. That is very high angle. Bob, my buddy in Lynn Haven, Florida, near Panama City, was running his radio using whisper, and so that was another receiving station. All right, so I ran the beacons from 10 a.m. to 12:40, and then that was why I launched a rocket, and then anyway, and then I switched over and made some regular contacts. All right, well, so for that 2 hours and a half roughly, this was the spot map. In other words, the stations that received the 40-meter beacon that was hooked up to the dipole, which was in an inverted V configuration, but I'll call it the dipole. And this kind of shows at 40 meters, it's not like 40 meters at nighttime, it's 40 meters in the daytime. But I'm particularly interested in stations close by, which my station in Dothan was one. That N4 KGL that you see is the transmitter. There's a little bit of play in the distances and everything because they just assume you're at the center of a 4-digit grid square. But anyway, you can see in Florida, KK4DIV received a spot or made a spot of the beacon. And I found out there's a station even closer in Graceville, Florida. And the call sign is NI5F. And then there's the mysterious WLO/05. And I initially thought, well, maybe that's a balloon or something else. I did some research and I found out a little information. I think it's on the next slide. But anyway, I got the best reception from the WLO station. All right.
How high up is the antenna, Craig?
Well, the center is about 22 feet, and it stretches out in inverted V fashion.
And the end's what, 5 feet up or?
Yeah, 4 or 5 feet up. Yeah.
Okay.
Well, like I say, you may read about NVIS and maybe they use the antenna at a lower height, but nevertheless, it's going to be, there's going to be high angle radiation. It could be a little better, maybe if it was completely horizontal and maybe a little lower, but I don't think it'd be a huge difference. So,
Oh,
but that could be another experiment with beacons, is to compare to an inverted V. I used to use poles that are about 10 feet high. So I would operate with a 40-meter dipole at 10 feet high all the time. And it was good for NVIS. All right. So I was most interested in the stations nearby. So we got some data on that. Well, that WLO intrigued me, and I believe I've traced it back to WLO, which I'm sure has a very long history. And what I can get on it now is that it's a maritime public coast station operated by Shipcom.
It's a high seas, two-way radio, high seas radio, commercial radio.
Yeah,
I had a friend that worked there.
great.
They got antennas, like 700-foot towers and stuff like that.
Well, I'm glad you brought that up because I did the usual Google Maps search and I found this picture. Okay. So this is looking down and I can see, I think there, well, 1, 2, 3, 4, 5, 6. I see 6 Yagis. But anyway, also it's connected with amateur radio in a way that there's a club station W4, what is it, LWO? And so anyway, they showed up as a receiving station on Whisper, and I'll show the data, but I got the best reception from them. So I just wonder what their 40-meter antenna was. It must be an excellent NVIS antenna. So I just talked to a friend I know in Mississippi. He says he's toured this. So I'd love to tour it. It looks, it looks awesome. For us hams, we would appreciate all this. All right, well, getting to some data, there's a website, whisper.rocks, and it will do some charts, many charts, but I thought this chart was helpful. And well, WLO was, nearby. Well, there's the kilometers there, but there's some error, it's not exact because of this, assuming you're at the center of a 4-digit grid square. But nevertheless, I was west of Dothan, I guess closer to Mobile. But anyway, it had the best reception. It was close, so this would be NVIS, and I had the best reception. So at first I kind of threw that out because I said it must be a balloon or it must be something, but not the case. Also, the Graceville station showed up, but the dipole did not show up as strong there. And kind of the third vertical line is KK4DIV and N4VSP in Lynn Haven. Now, on the actual Whisper.Rocks website, you can click on any of those dots. And so over time, there was different signal strengths. So there's kind of a band of different signal strengths. So it varied quite a bit. If you throw out the WLO, you can kind of see a curve through this data where around 400, kilometers, maybe 300 miles or something was pretty good, except for that WLO. So, so I'm kind of intrigued. Also looked up NI5F, and I wouldn't believe that in Graceville is just an awesome DXer there, and he runs Whisper all the time. So you can find friends through Whisper. All right. So now I think I'm going to mention later that QRP on 40 meters that afternoon was tough. So we'll get to that in a minute. Well, I could filter out for KK4DIV, and this was the actual spots that Bob got. And this is in local time, so he got it from 10 o'clock to 12:40. And but the let's see, the SNR, or the signal strength, signal to noise ratio, was not very high. I guess it, but nevertheless, it was being decoded. Now, he didn't decode. Now, he didn't have to be there. He was at Office Depot, but his receiver was picking up these spots. And it did not pick up any spots from the Alex loop. So, but I later found out it was a struggle to get anywhere on 40 meters at that time. So a different time of day or a different day, it could have been a different picture. And really, to get the best sense of this, you would run it over many days and have the benefit to see the range of values you can get. All right, this is the spot map for the Alex loop, mag loop. It really looks similar. There are fewer spots, I think. And it turns out that WLO decoded it. And the funny thing, the N4KGL, it's very confusing to me. If your call is N4KGL, and you take a beacon that's in 4KGL and do it, remotely and carry it around, I'm a little unsure how their database treats that. But nevertheless, I did get some spots for the Alex loop. Oh, what I didn't say was that the dipole I used N4KGL as a call sign. My receiver was quote N4KGL also. So a little confusing maybe for the system, but I needed a different call for the Alex loop. So I borrowed the club call W4RYZ. So you can see W4RYZ there, and you can see N4KGL to the east. So it decoded the loop here in Dothan. But for the dipole antenna, it didn't, or maybe it ignored it because it was the same call sign. So forgive me. I think, I don't know. I'd have to talk to a Whisper expert to know what it's supposed to do, but I'm kind of learning what it does. So I also did the chart, shows WLO. It's not, these values are way down from the dipole, but actually it was still pretty, I call that pretty good for WLO. N4KGL was here in Dothan. I didn't get it as strong. So, you get numbers, and it's another skill to interpret the numbers. So this was kind of a dry run of maybe experiments I could do in the future, and maybe others could participate in it if they're interested. So now there's one more dimension to this, and that is that here on my radio and computer, I was basically the computer, I was running the WSJT-X software while I was away, and it was, listening and doing decodes. I found out that it puts them in a log called all whisper or whisper all. And so I had a log of what happened. And in that log, there were decodes of both beacons. But for some reason, the global database ignored N4KGL. So that's pretty detailed, but so anyway, if you're doing FTA, a few keystrokes and you can be doing whisper. It's just a different mode of the same software. So I did some number crunching of both beacons, and it did turn out that the dipole was substantially better than the loop. And one reason that's the case is the Alex loop is like 15% efficient at 40 meters, where a full-size antenna is almost 100% efficient. So, but I'm really astounded at the contacts I've gotten on 40 meters. But anyway, here's some numbers from one trial. And whisper is a way to take your intuition and find out actual numbers. So that was fun. Okay, so at 12:40, I unplugged the Whisper beacons and I got on the air. I was operating with the ICOM 705 at 10 watts. And, I said, well, I'll call this guy doing POTO 40 meters sideband. And the guy was just very patient. It took at least 5 minutes to get my call sign. And it just showed that it was not the greatest time for 40 meters on that particular day, which was last Saturday. Later in the day, it probably improved. But at 1 o'clock or 1:30, it wasn't so hot. So anyway, I switched to 20 meters and contact, it's a different band, it's a different story, and contacts were pretty easy with the dipole and the Alex loop. And I made a 50 meter just for fun contact with the Alex loop. So that magnetic loop, this particular one's more efficient on 20 and 15. And I didn't have any problem making contacts. Okay, well, thanks for bearing with me. Are there any questions at this point? Okay, hearing none. We'll wrap up. Basically, I picked a rough time to evaluate NVIS. 40 meters was in poor shape, but I did get numbers. The idea was, will this technique work? So it will. It does. And I think 40 miles is extreme NVIS, but I did get whisper decodes from both the dipole and the mag loop. And as I mentioned before, the dipole is really a better 40 meter antenna because the loop efficiency for the size loop and its characteristics is not very good. I was getting surprisingly good reports in Mobile, Alabama, and I found out about that WLO over there. And but otherwise, the reports kind of got better out about 300 miles. I did learn that the Zachtek Whisper beacons were easy to use in the field. They did exactly what they were supposed to do. And for analysis, whisper.rocks, that's a real website, is an awesome whisper analysis tool. And the WSJTX software is very popular because that's what you use for FTA. But you can just change the mode to whisper and you'll get receptions. You could also transmit if you wanted to. It makes a log, but you can do a check box and it will upload to the Whisper database, and then you will show up just like all these other receiving stations. And so the bottom line is this a technique that I could use for future experiments. I have definitely heard that Whisper is QRP and NVIS go together. And there was a contest where basically your watts per mile was part of your score. And even though NVIS is short distance, the guy that won was able to turn down his transmitter down to well under 1 watt. And he got a great score, not working DX, but working short distances. So I'm interested in that. All right. Well, I do have a bonus. It was a rocket launch, and a ham that joins us here on Zoom that's not here tonight, but Ken from Enterprise came out, so he's a witness to all this. And I launched the totally tubular crayon rocket for Ken. And although I don't launch rockets all that often, it was successful. And so we were all very happy. All right. Well, I appreciate your patience working through this, but it does kind of tie NVIS and WSPR together. And so WSPR is a tool that can be used for whatever study you dream up. I did a saltwater effect study with WSPR in the past, so I had a lot of fun with that. So any comments or questions at this point?
So Greg, the WSPR beacons are transmit only.
That's correct.
So then I could run that on a long wire somewhere and have it running all the time, and it wouldn't matter if I was transmitting on my other system.
That's correct.
Okay, cool. That might be fun to set up sometime.
And it as far as the transmitter, it doesn't require the internet.
Right.
And so, you know, it would be cool. That's something that could be going on at the Panama City Clubhouse. If we had an antenna, we could hook it up to WSPR while we're not there. And W4RYZ would be, you know, received all over the world. I guess you have to consider what bands your antenna is good at. I guess my InFed pretty much works 80 through 10. So I turned on the WSPR beacon and put 80 through 10 in. It also does the WART bands. And so it's something you can play with. Joe, did you order one of these? I think you were interested in them. If you're still with us, he may not be with us. All right, group. All right. Yeah, Bob, this would be something fun to play with. And we could dream up more experiments to do.
All right, cool. Zachtek. Yeah, I got it.
Yeah, well, it's not the only one, by the way. There, Soda Beams makes one, and I've used those. This Zachtek's may be a little more versatile. And QRP Labs makes them. So if you want to build something, you can get a QRP Labs kit and build a WSPR transmitter. But well, see, Chris, we could do a study between here and in Ontario.
Well, I'm just sad that I didn't remember you were doing this thing. I remembered it about 2 in the afternoon. I thought, oh shoot, Greg's doing that WSPR thing. So I turned the radio on, but I don't know that you would have picked up on an NVIS antenna
Well,
up to here.
I did not get quite to Canada.
No.
Or maybe there just was nobody in Canada. Huh?
Well, that's the thing. And actually my 40 meter antenna is fairly good, but it's kind of orientated a bit north-south. So it would have been a challenge to pick me up, but next time you do it, I'll set my alarm and not forget.
It doesn't have to be 40 meters. We could do.
Oh, 20 would be no brainer. I mean, we catch it up in the
I'd
in
love
the
to do
car.
6 meters.
Yeah, yeah.
But my beacon doesn't do 6 meters.
No. Well, that season's coming to a close.
Yeah. But as probably Chris will tell you, you can kind of do. also get this information by FT8, and there's maps of spots, if you will, or
Yeah,
PSK
or
reporter.
FT8.
yeah, it's quite
Yeah.
a thing.
Yeah, PSK reporter. So, you know, but anyway, I enjoyed it. What I really want to do is put a beacon in Panama City and have a receiver up here, or vice versa. And because I want to know when I can talk to Panama City. So there's general guidelines, but I could use Whisper to help nail it. All right.